There it is. Nice. All right. Um, so welcome, Behavior Analysts Who Code, our monthly meetup. This month, I'm going to be talking about artificial intelligence and applied behavior analysis. Let me get these things clicking here. Before we get started, I'm a big fan of transparency in science and public presentations. And so at some point when I was engaged in the work that I'm going to be talking about in this presentation, I guess building the presentation and some of my own work, I was compensated by people that you see on this screen. I don't believe any conflict of interest exists, but we all know how automaticity of reinforcement works. So who knows? So there they are. I've shown you those people who've given me money. Additionally, I'm a big fan of open science and open source frameworks. So if anybody wants to download and use the slides, feel free to visit the website on the screen. You can download the slides and use them however you see fit. It's really up to you. All in all, it's probably the reference slides at the back of the deck that's going to be most useful, but it's yours for the taking. And there's the URL there, that short URL. Maybe I'll throw it in the chat here, so it lives. It's a terrible short URL. All right, there it is. Cool. All right. Now, also before we get started, I do want to take a quick minute to plug the group Behavior Analysts Who Code, kind of why we're all here. So for those who may not know, Behavior Analysts Who Code was started in this past year, in July of 2020, with the mission to create a space for behavior analysts who either want to learn how to write programs to get computers to do things for them, maybe for research or maybe to make their data analyses more efficient, or as a space for people who perhaps already code as part of their research or as part of their daily job functions, or to be a space where somebody who needs a programmer that also understands behavior analysis can find a group of people that have the skills that they need. In short, it's really a community designed to help behavior analysts learn, collaborate, and find others who can code. All the action really takes place in the Slack community, which you can join by going to that website in the upper right portion here, codingbehavioranalyst.org. And we also do have a very small social media presence, and you can follow and interact with the group there if you're really curious. But I think between the Slack channel and then these monthly meetups is really where all the action happens. And at these monthly meetups, we alternate every month between more informal conversations, just kind of about what people are up to, what they might need help with, and just kind of chat about coding and behavior analysis. And then on the other months, such as this month, we have more structured free CEU events where someone comes in and talks about something at the intersection of coding and behavior analysis. I will say Jake gave a fantastic presentation 2 months ago on computer vision, and those slides are available in the Slack channel, and we're also going to be posting them to the website, so you can check that stuff out there. This recording and the slides will also be available on the channel and on our website. And I do have a decent set of committed speakers lined up for the beginning of next year. And I know some of you are in the audience. I've seen you pop up. So be looking for an email when we can schedule those. So yeah, Behavior Analysts Who Code, come check us out, come hang out and chat about coding. The last bit of housekeeping before we jump in is that if there's anybody here that's interested in getting the BACB CEs for this event, you need to write down this code here. So throughout the presentation, there's going to be 3 codes that you'll want to write down. And at the very end of the presentation, there will be a link to a website where you'll put in those codes. And if all the codes match, then you'll get an email with your certificate as soon as I can do that. Oh, nice. Thanks, Jake. Fantastic. So it's in the chat, so I won't spend too much more time on it. And yeah, we'll kind of dive in. So over the next 50 minutes or so, maybe a little bit less than that, we're going to chat about 4 different areas at the intersection of artificial intelligence and applied behavior analysis. And we'll start by briefly going over what exactly artificial intelligence is via some examples and how that provides us with a bit of a working definition. After that, I'll talk broadly about the prototypical patient, client, or student experience in applied behavior analysis, and really many healthcare domains. Often a client or patient's experience in healthcare begins with diagnosis of some kind, which might be followed by additional assessments. From there, some healthcare practitioner designs an intervention and gets the client's consent. And in many situations, or I should say, then the intervention is implemented for some period of time. And then in many situations, the intervention might be withdrawn if it's an acute condition, or perhaps the intervention team fades to some kind of ongoing maintenance and monitoring if it's a chronic condition. And all of this entire client pipeline is encased by administrative processes and systems. And so as we think about this client pipeline, we're going to take a look at several examples for how artificial intelligence is being used by practitioners in ways parallel to applied behavior analysis, or in ways that are directly translatable to applied behavior analysis. More directly, in this section, we'll look at how AI is being used in work that can be translated to intervention on human behavior, or does involve intervention on human behavior. And we'll also look at how artificial intelligence is being used to streamline and make efficient the administrative systems and processes that wrap around this pipeline. Now, if you work in any kind of healthcare setting, I hope you come out of this second section understanding that artificial intelligence is already being used in some capacity to automate or improve just about every aspect of your professional work, right? It's here. And organizations and professionals that learn to practically adopt artificial intelligence seem likely to gain significant advantages over their competitors. But artificial intelligence also is not a silver bullet. And as with any technology, artificial intelligence has the potential to help, the potential to harm, and to create injustice and access to cutting edge evidence-based care. And so in the third section, we'll briefly discuss the use of artificial intelligence in healthcare and education relative to the bioethical principles of beneficence, non-maleficence, justice, and autonomy. Now, part of the reason that artificial intelligence is seemingly ubiquitous these days is because the computational power of machines and open source software makes access to artificial intelligence easier than it's ever been in the past. And so for people who are interested in getting started with artificial intelligence, which I hope is everybody by the end of this presentation, I'm going to close by describing some high-level, 3 different high-level roles that they can take to help increase the speed by which AI is used in ABA settings. Because I sincerely believe that artificial intelligence will be embedded in applied behavior analysis in some capacity in the next 5 to 15 years. It's really just a matter of when and by whom. So let's get started with artificial intelligence. And before I do that, I think I'm seeing people are having some trouble with the link to the slides. Is that accurate? Yeah. Let me do.
Yeah, the short URL link didn't work.
Short URLs. So what I did is I just uploaded the PowerPoint into the chat. Let me know if that works for everybody. I'll pause before I go on. Get a sip of water. Is that working? Silence, I'll take as a yes.
Yep,
cool.
Got him.
Nice, thanks, Jake. All right, so artificial intelligence. Let's get back in here. There we go. Yeah, artificial intelligence. So artificial intelligence, briefly, this is our 5-minute overview, is a broad branch of computer science. And the goal of artificial intelligence is to create non-biological systems that can independently mimic intelligent behavior. Often researchers are interested in the behavior of humans. And for our purposes today, we'll be thinking about mimicking the behavior of competent clinical or educational practitioners who are involved in behavior change programs of some kind. And when we stop and think about mimicking intelligent behaviors of humans, we have to start with the fundamentals. Right, so fundamentally, we recognize that humans can see with their eyes and they can differentially respond to the stimuli within their visual field. And the branch of artificial intelligence that creates systems that can see with their sensors and recognize objects in a visual field in the same way that humans might, it's called computer vision. Now, humans can also move fluidly through their environment without running into things. And so the branch of artificial intelligence that creates systems that move around their environment and are getting better at not running into things, this area is called robotics. And computer vision and robotics have historically advanced by improving how systems learn the shapes and features of objects in 2 and perhaps 3-dimensional arrays. And this approach can be referred to as symbolic learning because the systems are learning the environment as sets of shapes, right, or symbols. But it should be noted that alternative non-symbolic approaches to robotics and computer vision do exist today and are being studied. Now, one of those alternative approaches to symbolic learning that can be used to teach non-biological systems to mimic human behavior is through a data-based approach. Now, in this approach, researchers feed the software program lots of data so it learns both spatial and temporal patterns between the variables that are in the data set. And this is the field of machine learning. Now, one popular way machine learning is being used is with verbal behavior or language. And humans can emit and respond to verbal behavior. And artificial intelligence systems focused on this fall within the field of speech recognition and are present in many of the devices you probably have around your house or perhaps carry in your pocket. Now, humans also can read and write text from a given language or maybe multiple languages. And those textual symbols can then influence the behavior of the reader. And this is the field of natural language processing, right? Teaching non-biological systems to break down the stimulus features of a text to understand the text and then respond appropriately to whatever that written text is. Finally, humans can engage in complex tasks involving response chains, problem solving, and sophisticated verbal relations. Now, though many more traditional machine learning algorithms have been successful in this domain, recent technological advances in deep learning and neural networks have allowed computer systems to make complex conditional discriminations and to engage in complex change of behaviors that are well beyond the average human. Now, at its core, what all these are really good at is the ease by which computers can identify symbols and complex patterns in large data sets. So whereas humans are decent at learning patterns in data that involve 2 and perhaps 3 dimensions, computers can learn patterns in data that involve hundreds or thousands of dimensions. And computers can efficiently complete complex mathematical computations that are well beyond the average human. And so this ability to allow computers to efficiently analyze large, multi-dimensional data sets to identify patterns, detect relationships, and make predictions that humans can't even come close to. And so artificial intelligence is great at finding patterns in data sets that have hundreds, thousands of dimensions. And so we can feed information about the world to systems who have the capability of detecting patterns and symbols in our data. And then we can use those identified patterns and skills to predict or to mimic the many behaviors that humans might engage in with that information, right? So we collect a bunch of data, analyze it for patterns and symbols, engage in some behavior. That's essentially artificial intelligence in a nutshell. And so you can imagine if artificial intelligence can be used to mimic behavior, you can imagine that some people have been interested in mimicking the decisions and behavior of healthcare providers. So here, researchers are using artificial intelligence in healthcare in several broad categorical ways. First, biological life is complex. We often will break behavioral phenomena of interest down to a few dimensions because that's what we see in published laboratory research, or because maybe that's all that we can work with. But we know that dozens or hundreds of variables come together to interact dynamically through time to control our behavior and other physiological processes. Right? So multiple control is what we mean by response probability. And so researchers are using artificial intelligence to improve the decision-making of healthcare professionals by identifying patterns in large multivariate data sets that go beyond the traditional clinical phenotype of presenting symptomatology. Right? If we know multiple control behavior is a rule, why not play with multiple variables? And artificial intelligence allows us to play with many variables very easily and at scale. Now, second, researchers are using artificial intelligence in healthcare to automate routine clinical decisions that extend the reach of healthcare to populations that wouldn't be able to receive medical care otherwise, or so that the volume that people can receive care by one provider can be increased. Now, when discussing the growth of certified behavior analysts, a common conversation piece seems to be the need for more certified behavior analysts to meet the demand. But this is true of many healthcare professions, doctors, nurses, technicians, and so forth. And so one way that other fields are addressing the projected practitioner shortfall is by automating the routine and easy stuff with artificial intelligence. And this is really in the same spirit of Skinner from decades ago with his automated teaching machine, right? Our tools today are just a lot better. Now, much of this work, again, involves feeding a large amount and variety of health record data to artificial intelligence algorithms in order to mimic whatever clinical or educational behavior we're trying to improve or automate. And because there are potentially thousands of different healthcare related behaviors that practitioners can engage in, different researchers and clinicians have worked together to focus on specific behaviors and have fed large amounts and variety of health related data on specific behaviors that span almost every phase of client or patient contact with healthcare practitioners, from diagnosis to intervention design and implementation, through ongoing maintenance of chronic treatment, or the withdrawal of acute treatment accompanied by some kind of symptom monitoring. Now, a lot of the work in the diagnostic and assessment realm has focused on analyzing images to detect the presence or absence of cancer or other diseased organs. And again, this is largely the domain of computer vision, right? Identifying and classifying objects from two-dimensional image array. And a lot of the hype in this realm has come from algorithms and AI technologies that repeatedly outperform medical experts in the diagnosis of diseased organs from these medical images. But I do want to quickly follow up with the caveat that these are in very prescribed instances of diagnosis, right? So an AI tool that is great at, say, identifying cancerous lung cells is unlikely to be automatically good at identifying cancerous heart cells or cancerous brain cells or predicting pneumonia. Right? These are typically very highly specialized tools that are outperforming experts. Now, once a diagnosis has been made, artificial intelligence can be used to automatically generate diagnostic reports that are unique to the medical providers, the patients, and the insurance company. Additionally, because computer vision is used to make the diagnosis, we can precisely quantify how confident we are that the diagnosis is correct. And this precision in diagnostic accuracy can be included in the report to aid intervention decisions. For example, if you were to ask a human, how confident are you that your diagnosis is correct? The answer is likely to be vague and of questionable accuracy. But computers can give me a precisely specified range, right? The probability this tissue is cancerous is 80%, give or take 5%. And this range is based on historical data, not subjective guesses. And as new data comes in, it's likely going to get better. So the point here is that artificial intelligence often allows us to get more accurate diagnosis automatically, and we can generate diagnostic reports that are tailored to the reader, that includes greater amounts of information that's of higher precision and unique to their behavior change that we're interested in. Now, artificial intelligence has also been used to analyze patterns in streaming physiological and behavior data via wearable technologies. Now, the idea here is to gather data on physiological and behavioral patterns over time. And as we're collecting these data, we start to understand what a person's baseline looks like, and then we can identify when something changes in a direction suggestive of a medical or behavioral problem. And then once a potential problem is identified or predicted, the individual or their healthcare provider can be notified and some kind of action can be taken. And again, because artificial intelligence can incorporate hundreds or thousands of variables with relative ease, the time series and predictive analytics in this realm are a level of sophistication that's head and shoulders above the visual analysis that behavior analysts have traditionally used, and possibly beyond what some behavior analysts have even contemplated in the past. Now, artificial intelligence has also been or can be used to analyze electronic health record data, clinical notes, social media posts, the videos people have watched, and people's search history to predict suicidal behaviors and other low frequency, difficult to predict, but high intensity behavior patterns. Right? Facebook and Twitter already do this with your data. The idea here is to use those same data streams and analytic methods, but to focus on the prediction and intervention of health behavior. Now, as a final example, artificial intelligence has even been used in domains more directly familiar to behavior analysts working with individuals with autism and developmental disabilities. Here, researchers have used wearable sensors and video cameras placed in heavily outfitted therapy rooms to collect data on multiple people's movement within a room over time. And then once we have these data on the behavior and the environment, the researchers have shown that you can use artificial intelligence to automatically detect and quantify behavior and use that information to analyze the function of a challenging behavior. Now, thus far, I've seen this with self-injurious behavior and stereotypy, though I wouldn't be surprised if other behaviors have been targeted as well. And you can imagine that with technology like this, it's a small step to completely automating data collection in ABA sessions, right? So the technician or the teacher can focus solely on interacting with the client or the student. You can imagine you can also pair this with a little bug in the ear and real-time staff coaching or prompting based on the data that's streaming in, and you can do some really cool stuff. Now, in total, these are just a few examples of how artificial intelligence is being used to automate or improve the accuracy of diagnosis and assessment in the healthcare space. Now, once assessed, obviously this information can be used to recommend an individualized therapeutic program that's tailored to the patient in order to maximize the probability that the patient or client obtains the best possible outcome. Now, in medicine, this is sometimes referred to as precision medicine, but it's just the idea of tailoring an intervention to each unique individual based on the totality of their presenting facts. And if you're a healthcare practitioner, tailoring interventions is not really a new idea, but artificial intelligence allows us to do this with a greater number of variables and to automate the process. Examples in this realm include using all available biological information about cancerous tissue and someone's genetics to identify optimal treatment combination, which drugs to use, and what dosage is predicted as being optimal. Work in this realm has also used natural language processing of patients' written descriptions of their experience during a psychedelic-assisted therapeutic event. And these data were then used to predict the type and amount of follow-up treatment that the individual may need in order to successfully quit using drugs, to reduce chronic symptoms of anxiety or depression, and to cope with terminal illness. Now, researchers have also used artificial intelligence to identify how different behavioral groups will cluster together functionally. Okay, all healthcare practitioners have constraints to what they can do because of time, money, limits to human learning or physiological adaptability, or other resource limitations. And so by understanding how many different behaviors group together functionally, healthcare practitioners can use this information to determine exactly how to best allocate their time and limited clinical resources to maximize the therapeutic effects of an intervention, right? If I can only focus on 5 things, which 5 things give me the greatest spread of benefit across someone's entire behavioral repertoire? Relatedly, researchers have also used artificial intelligence to predict educational intervention outcomes with over 90% accuracy. Here, the data were student assessments, teacher characteristics, available educational tools in the classroom environment, and what resources the school districts had available. In turn, these predictions allowed the schools to identify which students needed additional assistance, the types of additional educational resources and tutoring that any one student might need, and the teachers who seemed to struggle the most with students with specific academic abilities, right? Maybe I don't do a great job of helping kids catch up in their English literature skills, but someone else out there does, right? So kids who are already behind their grade level in English literature, they shouldn't come to me to get any kind of help whatsoever. We should allocate them somewhere else. Now, central to this idea is the fact that human interactions are dynamic, socially nuanced, and they include a host of variables that are not always observed or measured. So a behavioral or educational intervention delivered by me might look slightly different than the exact same behavioral or educational intervention implemented by someone else. And so based on these differences, researchers have used artificial intelligence to optimize the patients that are assigned to a healthcare practitioner based on the client's presenting symptomatology and the doctor's demonstrated skill in treating different medical conditions or implementing different interventions. And this optimization of a doctor or behavior analyst clinical caseload can be used to help keep them from burning out and to maximize their ability to help the clients or patients that come to them for services. On the flip side of this interaction, artificial intelligence has been used from the patient's perspective to match them with a team of healthcare providers that are most suited to all their presenting health concerns, as well as their cultural background and any other dimension along which we have patient and provider data. So in total, these examples highlight that once the details are known regarding what exactly is going on with the patient or client and why those health concerns are occurring, artificial intelligence can be used to tailor intervention design and to match clients with treatment teams to optimize the likelihood of the best outcomes possible for everyone. Now, at this point, it's 8:30. Let's take a quick pause for that second CEU code. And I'll get a drink. Throw it in the chat here. Oh, nice. Thanks, Jake. Oh, thanks, Anna. Yeah, you guys are great. Sit back and relax. All right. Second CEU code's in the thing, so I'll keep rolling. So once interventions have been designed, artificial intelligence can be used to implement intervention as well. So one significant impediment to maximizing intervention outcomes stems from healthcare providers' struggle to keep clients engaged in an effective intervention and to maintain treatment fidelity once an intervention is started. And patient engagement and adherence is important because the more patients proactively participate in their own well-being and care, and the more likely patients are to adhere to recommended interventions, the better the healthcare outcomes and the patient's overall experience. As a result, artificial intelligence has been used to provide real-time delivery of intervention-related content or intervention-related support that has been adapted or tailored based on the data collected from that individual. For example, these just-in-time adaptive interventions have been used to increase physical activity, improve dietary patterns and food consumption, and to improve health-related decision-making in everyday environments. In the same area, artificial intelligence has also been used to provide individualized prompts to refill and take prescribed medications, as well as prompts to make healthier decisions that decrease incidence of diseases such as cancer and to reduce addiction-related behaviors such as drug abuse and gambling. Now, related to this idea of tailoring interventions over time, artificial intelligence has also been used to automatically analyze single case intervention data with error rates lower than the best structured decision criteria. And you can probably imagine if this were used well, artificial intelligence with single case intervention graphs could allow BCBAs to automate those routine clinical decisions across the clients on their caseload. And in turn, this would free them up to spend more time on the difficult decisions or the more challenging cases, or to increase the overall number of client programs that they supervise at any one point in time and close that BCBA shortage that we often hear about. And again, it turns out that data plotted over time is the primary method that many different industries use to think about and analyze their data. And artificial intelligence allows analysts to incorporate greater complexity and a greater number of variables into their analyses to predict behavior over time. And these are all open source models that places like Facebook, Amazon, and Google make freely available for analyzing time series data. Finally, I'd also like to highlight two other really interesting areas of artificial intelligence that are more directly related to working one-on-one with someone with autism or developmental disabilities. One exciting area uses speech recognition devices that help individuals with speech disabilities communicate vocally and more clearly. Now, in the right hands, you can imagine that these tools could be combined with simple shaping and chaining procedures to shift these tools from vocal amplification devices to therapeutic devices that increase the intelligibility and comprehensibility of someone's vocal speech. Now, another really exciting area in the intervention implementation space is facial recognition software. Now, researchers here are using artificial intelligence to identify the emotions that someone displays in real time. And behavioral practitioners could use this technology in several ways. One would be to help individuals learn to recognize the emotions that other people display, right? Perhaps as a phone app or maybe some kind of augmented reality. Additionally, this technology could be used to give a learner immediate biofeedback on the emotions that they may be displaying and that they might be working to better associate with their private events. So in total, artificial intelligence is already being used to deliver or to improve the implementation of behavior-related interventions, or to improve the efficiency of clinical decisions that are made relative to behavioral interventions. And several low-hanging artificial intelligence fruits seem to exist in the areas of speech recognition and facial emotion recognition. Now, at some point in time, Some patients or clients may fade out of intensive interventions because an acute condition has gone into remission or because a chronic condition can be successfully self-managed. Now, the majority of work in this area has used some kind of automated hovering or ambient intelligence to collect ongoing data about the person in many of the same ways that we've already discussed. That is, wearable technology or environmental sensors and cameras can be used to track and analyze patterns in what people are doing and where they're going. In turn, these data have been used with artificial intelligence to predict if and when people will relapse to using drugs after they successfully quit, or to predict when someone might experience a relapse of cancer following successful treatment and remission, or to predict when someone might relapse to severe depression following the successful behavioral intervention and predict that they might be at risk of suicide. Now, though this idea of treatment withdrawal and avoiding relapse has long been considered a distinct piece of the intervention puzzle, when we view this through a different lens, it's hard to know whether someone is an ex-client or ex-patient or a future client or patient. They're just on pause. And so in addition to some of this digital hovering technology, much of the work on intervention withdrawal and monitoring can be thought of similarly as the work in the diagnosis and assessment realm, right? Just perhaps we have a bit more baseline data here on the individual surrounding their behavior and what works. So artificial intelligence with automated hovering and ambient intelligence allows us to take a view of healthcare as a cycle, as opposed to thinking about treatment as a linear pipeline with these kind of one-off interventions. Now, finally, wrapping around the entire prototypical client experience and treatment pipeline are a host of administrative systems and processes to support each of these steps. Now, in this space, administrators are using machine learning to automatically extract and synthesize the massive amounts of research literature that are being published. And this condensed research can then be given to clinicians to aid their decision-making or to help them stay abreast of the literature. Now, in this area, some researchers are also trying to predict the next major discoveries and to guide scientific researchers toward fruitful and impactful research topics. And the same strategy can be accomplished with clinical research and identifying opportunities to enhance the clinical services that we deliver, right? Find out where the gaps are in the literature and feed that to the clinicians and the researchers out there. Now, outside of the research literature, artificial intelligence is being used to analyze patient flows through hospital administrative processes, which many of you can probably attest can be an absolute nightmare of inefficiency and lack of clear directions. And related to this, artificial intelligence has been used to optimize patient and staff scheduling based on the times, days, and weeks when people are likely to seek services, and to combine this with staff availability. And researchers that are studying the logistics of moving goods around the country have also used artificial intelligence to find optimal solutions to the traveling salesman problem. That is, how do I plan the optimal route to go from one location to another when I know I have to make certain stops along the way? So combining this information with staff availability, you could create tools that would be of tremendous help for ABA agencies trying to coordinate people's work and personal schedules with client session times in order to reduce the amount of time and distance that RBTs must travel each day. Now, outside of systems analyses, artificial intelligence has been focused on analyzing the clinical decisions that healthcare practitioners make. And in turn, this allows them to determine what the optimal cost-effective intervention strategies are for different patients based on their unique conditions. And once the optimal intervention path is known, we can create clinical decision-making aids that reduce the errors that healthcare providers make. And we can provide healthcare practitioners with ongoing feedback about their performance to improve the interventions that they deliver. Lastly, all those topics related to optimizing caseloads for a single healthcare provider, patient-provider matching, and automating report generation could be additional examples of the administrative use of artificial intelligence. And so to kind of summarize this area, healthcare practitioners don't operate in a vacuum. Rather, they are embedded in a larger, complex, and dynamic organizational system. And organizational systems collect and use data to improve efficiencies. And artificial intelligence can or is being used to improve these areas of human behavior. So in short, many of the behaviors, decisions, systems, and processes that healthcare practitioners engage in on a daily basis, or perhaps hourly basis, are beginning to be touched by artificial intelligence to improve the speed, accuracy, efficiency, reach, and scalability of access to high quality healthcare services. And this includes applied behavior analysis. Right? This future of artificial intelligence in healthcare is already here. It's just not easily accessed or evenly accessible. But again, those who can leverage the tool that is artificial intelligence appear to be at a significant advantage. So artificial intelligence involves computers learning about patterns in complex data sets without being explicitly programmed to do so. And when we turn this toward healthcare, this powerful tool is capable of broadly improving the efficiency and effectiveness of healthcare service delivery, including applied behavior analysis. But as with any tool, artificial intelligence can be used by humans in many ways. And because artificial intelligence is likely coming to our everyday clinical or educational practices at some point in time, it's also helpful to have conversations about the ethical use of this tool in ABA settings before it becomes ubiquitous and perhaps inappropriately used. Now, to begin, there are certainly many benefits of bringing AI into ABA settings. Okay? First, artificial intelligence algorithms are typically designed in collaboration with multiple experts from the clinical domain of interest. And additionally, artificial intelligence models can be updated on the fly as new information and data becomes available. So practitioners who learn to incorporate AI to aid or supplement clinical decision-making have the benefit of real-time access to all the domain expertise that went into making the AI tool. And they have the added benefit that the expertise is always providing the near optimal recommendation based on how the model was trained and the data from the unique situation that the tool user is specifically facing. Now, second, where artificial intelligence can automate clinical decisions, the ABA organization essentially has access to an expert trained system that does not get tired. It can work around the clock. It doesn't require vacations, breaks in a workday, or employee benefits. And it can analyze data from hundreds or thousands of clients simultaneously across the hundreds or thousands of variables that might be impacting their progress. And because computers are not humans and they don't make the same errors in judgment that we do, artificial intelligence systems always find the ideal solution based on the data we give it and the outcomes that we select, most of the time anyway. And again, these AI systems can make ideal decisions using all the data available for a client and for all the dozens or hundreds of decisions that need to be made for each client and their program on a daily or a weekly basis. So at least as a supplement to BCBA decision-making, incorporating artificial intelligence into our practice is likely to only increase the amount of benefits that clients gain from ABA services, as well as the accessibility of those services to a greater number of people. But these benefits don't come without a cost. For one, creating and deploying AI models can sometimes require thousands or hundreds of thousands of data points. It also requires access to trained computer scientists, data engineers, and the relevant domain experts. It also requires the hardware and software to store, maintain, and operate the AI system. All of this requires money and time that could be allocated to improve existing clinical systems in an organization. And so the ethical question is if it's okay to perhaps hinder client progress by allocating resources to build out a system that will benefit clients at some future point in time. Additionally, all the data for these models needs to come from actual clients. And the more personalized the information that we include in the model, the better the model is likely to perform. And accessing and storing data and developing and using these models with many clients that are required creates opportunities where health and educational privacy can be compromised. Now, a third area for potential harm mitigation involves transparency in the AI process and what happens when an AI system makes a mistake, right? Who's held responsible? Is it the people who decided what data to collect? Is it those who actually collected the data? Those who get the data to the data scientist that's maybe building the AI tool, the clinician that then uses the AI tool and is making the decisions? Or is it the decision makers who funded the AI tool creation and gave it a scope and focus? To mitigate potential harms, it's important that we can explain how these models work and understand when and how errors are made. And then we also need to be upfront with everyone that's involved in that AI pipeline about their role being held accountable for any harms that may occur to a patient in the future. Now, a related potential harm involves models that are developed with a bias to favor particular groups of people, or that are developed with a bias to favor clients who present with particular behavioral repertoires or intervention goals, or a bias because the data that we have put into the system are less than perfectly accurate. And this bias may not arise because of any malicious intent of the people that are building the AI tool, but naturally because the data that we have collected aren't representative of all the people for whom the AI system will be used. You know, at the end of the day, artificial intelligence is high volume computation involving complex math using the data that we give it, right? And so as the saying goes, you know, garbage in, garbage out. And so harm following biased recommendations might occur if we're not proactively vigilant about identifying, removing, or counterbalancing these biases from our data and from our models. Now, a third ethical domain for consideration is autonomy. Now, autonomy in healthcare context generally refers to the right that we have to make independent decisions about our body and about the healthcare that we receive. Now, when extended to health-related data, autonomy is the right to know how my health-related data is being used and to control who that data is shared with. Now, AI models are significantly improved when more data is used to train the models. And important ethical questions here involve who owns the data that's collected by RBTs and BCBAs? Is it the client? Is it the organization? Is it the electronic data collection platform that I've chosen to contract with as an organization? And can the organization or the data collection platform use my data however it wants once the data is collected and in their system? Additionally, should clients have to opt in to sharing their data or opt out of sharing their data? We know from a large body of research in behavioral economics that the default option we choose to present to clients is likely what 80 to 90% of the clients will stick with, right? So this becomes a non-trivial decision. Lastly, an ethical question surrounds how a client's decision to share their data should impact their access to the resulting tools. Right? Artificial intelligence is very good at what it does. And without my data in the system, when the model is trained, the model may not easily generalize to my particular case. So what this means is that AI tools without my data may not benefit me or might even harm my progress because the tool recommends something that's less than ideal for me, right? It's not generalizing to my case well. But just because I don't want to share my data shouldn't mean I get anything less than the best evidence-based care. Now, a final ethical domain of relevance is justice. Now, traditionally in healthcare, justice refers to treating people equitably. Now, with artificial intelligence, justice refers to ensuring that clients have equitable access to the benefits that occur by incorporating AI into the services delivered by an ABA agency, as well as fair distribution of the costs that are associated with developing the system that everyone benefits from. Finally, accurate AI models that generalize to as many clients as possible require data from as diverse a group of individuals as possible. And models are likely to perform poorly if derived using data from other clients with different behavioral repertoires, or different behavioral plans and access to resources, or different cultural backgrounds, or even differently skilled RBTs and BCBAs. That is, we know that there are dozens or hundreds of factors that go into the successful delivery of applied behavior analysis interventions. And every dimension that isn't sufficiently sampled and included when developing the AI technology increases the likelihood that the tool won't generalize to clients who differ along dimensions that are not included or not sufficiently sampled, but that are important predictors. And so ethically ensuring just access to accurate models will require that all people are represented and included in developing and validating the models. So to summarize the ethical considerations, AI is a tool designed by humans. And this tool called artificial intelligence can and is being used to benefit people in many amazing ways. But even if the tool is only being used to benefit people, there are many ethical questions that we'll have to consider in how that tool is designed, developed, and deployed. Specifically, we need to determine how we'll avoid foreseeable harm, how we're going to respect the privacy and the decisions about that clients make about their data and our use of the tool in their healthcare interventions, and to ensure equitable access to the benefits and the costs that are associated with the technology. All right, so those are some of the ethical concerns of using AI in healthcare context and in ABA as well. Now, at this point, I hope you've been a bit overwhelmed with the extent that AI is being used in healthcare context and in ways relevant to applied behavior analysis. And I hope you also have a sense of urgency that this is already here. Right? There are some very serious questions that I think we need to be asking, and perhaps most importantly, that you should be involved somehow. And so I'd like to close out this presentation by discussing how you might go around playing with artificial intelligence in your practice or research. Now, though there are many different ways that you could do this, it seems like there are at least 3 paths you could take, which I call the designer, the implementer, and the supporter. Now, the designer would be someone who is thinking, this is my jam. Right? Artificial intelligence is going to play a dominant or a primary role in my career. And I'm really interested in trying to figure out how to bring AI to an area that's not currently represented, or maybe only tangentially represented. Now, taking this route means you're likely going to have to learn some new skills. I suspect that if people are watching this presentation, that they probably have or are developing the behavior analytics skills you need, right? The domain knowledge. But if you want to get involved in helping to build and design the AI tools that will be used in some new area or in some new way, then you're also going to need some skills in mathematics and statistics, as well as skills in computer programming. Now, this doesn't mean that you necessarily need to get a PhD in these areas, right? There are many ways that you can develop these skills by spending little or even no money, but you will need these skills, and you'll have to be relatively proficient in these areas. And mentors are always a good thing. And so for people that are interested in this route, I would say feel free to contact myself or Beth Garrison, because I know she's in the audience and she's getting her PhD in artificial intelligence. And we might be able to provide you with some advice on what exactly this might look like based on current interests and your current skills. Now, closely related to the designer is the implementer. Now, this might be someone who is also thinking, AI is awesome, and I'm really interested in perfecting how some AI tool is going to be used in my practice or research. Now, the implementer might be someone who generally knows how the tool is made and how it works, right? They understand how a saw is built and the general mechanics of how it cuts wood. But the implementer is likely more focused on becoming an expert at using the tool for some specific goal. Right? So whereas the designer is interested in building the perfect saw for a situation, the implementer is interested in perfecting their ability to expertly use that saw in the appropriate situation. And so if this is your route, your next steps would likely be to find that practice scenario, right? Find that situation where AI is not being used and you're really interested in automating it or making it more efficient, right? We walked through a bunch of examples today, but the literature is large and growing, and you're probably just gonna have to dive in. And in kind of loose analogy, the relationship between the designer and the implementer might be similar to the relationship between researchers that are pairing up from the experimental analysis of behavior and applied behavior analysis. Right? It's challenging to have all of these skills in a single individual. Right? So the designer is likely to spend more of their time developing their skills to perfect the AI tool, and the implementer is likely to spend more of their time developing the skills to perfect the use of the tool in the applied setting. But both the designer and the implementer need each other. Now, finally, there may be some of you in the audience that think AI is amazing, and I might dabble with AI throughout my career, but I'm not really interested in learning all the math and computer science, nor do I really want to go through the long, arduous journey of figuring out how to effectively implement AI tools in efficient ways. But I'd love to support this work and help in any way possible. And so if this feels more your style, you can get started in AI in 2 primary ways. First is by helping the designers and implementers beta test their tools and products outside of the development environments. right? Every instance of generalizing an AI tool with new people or to a new situation is going to involve mistakes and errors that need to be cleaned up. And so beta testing these tools as they're being developed helps the designer and implementers fix these bugs. And it also provides them with feedback on how helpful and useful the tools are to you, right? The eventual end user of the product itself. And this also carries the bonus that you get to access cutting edge technological tools that aren't yet widely available. Now, second, and even more critical realm is to provide data to the designers and implementers. Right? As we've discussed already, AI tools feed on data, right? They require a lot of labeled data to build models of sufficient accuracy and generalizability to be used outside of research settings in real world environments. But data is expensive to collect and curate, and behavior analysts are sitting on troves of data that could be leveraged to do some really cool things. And so another way that you can support your designers and implementers is to find your local AI researcher and see how the data that you have access to could be leveraged in their research and their work. All right, so we've covered a lot of ground today, and we're actually doing okay on time. To summarize, artificial intelligence involves providing instructions to computers so they learn about patterns and data sets. Now, often researchers are interested in using artificial intelligence to mimic the behavior of humans. Now, in this capacity, artificial intelligence is increasingly used to aid clinical decision-making in many areas of healthcare, and it is beginning to be used in ABA-related settings. Now, incorporating artificial intelligence into ABA will likely bring tremendous benefits in the effectiveness and scalability of ABA services. But significant potential harms come with artificial intelligence systems that can likely be avoided. And so as a field, we'll have to make difficult decisions about how client data will be collected, how client data will be used, and how we can ensure equitable access to the powerful tool that is artificial intelligence. And for those that are interested in helping to shape how artificial intelligence will be used in ABA, several possible paths seem to exist that will allow you to have a significant impact on this area. Right? You could become a designer, an implementer, or a supporter of artificial intelligence in applied behavior analysis. So take some time, do some soul searching, and pick your poison for how you'd like to get involved in helping to further bring artificial intelligence to applied behavior analysis. With that, I want to thank you all for coming to our Behavior Analysts Who Code monthly meetup event. There is the third CEU code that you'll need to write down, as well as the terrible, nasty link that you need to put into your web browser to submit the codes to get the CEs. So with that, we can open it up for questions. I'll leave, oh, nice, you got the code in there. I'll get the link in the chat here as well. And then I'll shut this off so we can chat. But people can feel free to fire away questions or whatnot now if you'd like.
Hi, can I make a comment?
Yeah, go for it.
So I'm Anna, I'm from New Zealand. So we are already
Yeah.
Friday evening here.
Oh, I'm jealous.
Yes. So I am doing a PhD using artificial intelligence and
Awesome.
behavioral data. It's very experimental. So
Yeah.
I would like to share a little bit what I'm doing.
Oh, that's great. And if anyone in the audience has data, they can give her.
So we are using, I know that you mentioned about big data. We are using a third generation technology, and I wanted to comment on that because I find it interesting. It's called spiking neural network. So the good thing with this technology that we're using is that you don't need to average the data and you don't need big amounts of data. That, you know, in a way that's good for us as practitioners. So I'm using just 6 individual data sets. You don't have to have big amount of data, and you can actually use the data as they are. You don't need to process the data. So this type of technology I think is closest to us as behavior analysts, because you just use the data as they are, and you have the time component included into it. So the first experiment that we did, we had to use pigeon data from the experimental lab because of this problem that you mentioned. It's hard to find data and use data and from humans as easily. And we used choice research data. So, there were pigeons in labs making choices on concurrent schedules of reinforcement. And I actually tried to apply a question that I had as a practitioner, like how do we actually handle treatment fidelity as easy as possible, because it's usually an issue. Like, we do spend time designing interventions, but how they are implemented and how the consequences are given to the target behavior is usually an issue. So I went back and did a retrospective analysis. So the prediction was in the past. We had the current behavior of the pigeons, and we wanted the model we created to predict where that behavior was trained. And I find some practical value in that, because in real life, we don't always have the luxury or the luxury of knowledge, or to check the conditions or the past history of the behavior that we have in front of us. And I thought of going into the past. It could be valuable, and I would appreciate your a little comment on that, because it's so novel. I'm not sure if we're heading towards the right direction.
I mean, it anything that allows you to get some of the gains with less data, I think is amazing. What I'd be curious about with those 6 pigeons is how many observations you had per each. And then were you building a model per pigeon, or were you still incorporating like were you doing individual level modeling?
Yes, we
I have a
did
lot of
different.
questions.
Yes, we actually did different variations to see, what works. So we had
Oh yeah.
6 pigeons data, and we used 5 pigeons data sets for training the model
Oh, and
and
predicting.
1
So
for
you were
testing.
generalizing.
But then
Yeah, that's
we
cool.
actually did that for, we did all the combinations,
Mhm.
to see in case, an individual data set is interfering with the
Yeah.
outcome. And then we actually compared the outputs with the actual pigeon's behavior.
Oh, so you were predicting what were you
So
predicting, I guess?
So we were predicting the reinforcement history, like the concurrent schedule of reinforcement they were trained under. So we only fed the model with the left and right responses of the pigeons, and we say, tell me where that behavior was trained. Tell me where it was learned, under which environment. So we went back to the
That's cool.
past. The prediction was, there's no prediction in the future.
Yeah,
There's
I see what you're saying.
regarding the past.
Uh-huh.
Thinking that usually we don't know the learning history very well, and we don't know what has worked for the behavior, and maybe having a tool that can give us an indication might help for building or shaping the intervention that we have in front of us. That was the
Yeah.
actual thought.
I mean, I think so. I haven't worked in ASD or DD for a while, and shifted more to like pro health behavior in the last 6 years. And one of the things that I felt spoiled coming from like EIBI, where you may not have a bunch of data on the individual's history, but you get enough baseline data, and then I'm with you 40 hours a week, so you like figure the kid out pretty well. But with verbally competent adults, where you see them maybe like 15 minutes a week or 45 minutes a week, we can look at some of these pro health contexts. The ability to, I'll kind of rephrase it based on what it kind of sounds like you're doing, the ability to recover that learning history, I think would be amazing if you could pull that off well. That kind of a tool, like that's the gap.
I think I'm very
I don't have
lucky because we are working with the experimental lab,
Mhm.
and then we have the artificial intelligence lab in Auckland, and then I'm coming as a BCBA.
Yeah. Oh, what a
So
great crew.
what you said, it's really hard to learn all the maths. The hardest part is when you have a question, what best algorithm fits what you're
Mhm.
trying to find. That's what I find difficult as a practitioner. And
Yeah.
if you don't have someone working with you, I think it's impossible for us as behavior analysts to solve the problems.
Yeah.
It's really hard. You need to have someone that can pick and choose the algorithms or the networks that might suit our question.
Mhm.
That was the hardest part for me.
Oh yeah, I bet.
Journey.
And there's even a moving from the academic setting, I guess where I am now too. There's also another really interesting thing that I didn't really appreciate, and that when you go to transport the model and when you deploy it live on the world, there are a bunch of constraints on like size of the model, how often is data going to be hitting this, all sorts of engineering constraints, like for lack of a better word, that also come up too that I didn't really appreciate. So it's like, how do you pick the best way to approach a problem mathematically that fits like our behavior analytic theory academically, and then also on top of that, how do you push that into the practical constraints of the setting you're in? And there's a lot of fun problems. That's cool. I'm just rambling right now, but I think it's a really cool project that you're getting into. I think it's really neat.
We're thinking of getting a first publication out, but I wasn't sure what kind of journal will be interested.
I think a lot of, well, maybe that's a bigger conversation. What I'd be curious about, so I know there are, Facebook or Twitter, right? They track like one person. They can do that individual level modeling and build a model based on one person's data to predict that person's behavior. And so I think if you did that, then any of the traditional behavior analytic outlets would be amazing. I bet JAB readers would eat that up. Yeah, I don't know if other people in the audience have thoughts. Behavioral processes would be good. I guess, who's your audience? Is it behavior analytic audience or is it AI researchers?
Well, it should be behavioral.
Oh, yeah,
Well, we're using a technology as a tool. So we haven't, we have constructed a model by having algorithms there. It's not like we created an algorithm,
right.
So because I think that's
Yeah.
a total different story to have engineers to create new algorithms for your data.
Oh yeah.
So we started by testing the existing algorithms that are out there, how they could fit with behavioral data, observable data.
That's awesome. I say go JAB then. Go JAB or behavioral processes. And I'm being purely selfish here because I want to see that research come across my desk. That's cool.
What was the name of the neural network?
Spiking neural networks.
Yeah, have you played with that, Beth?
And, not so much. How many
neither
data
do I.
points did you have? You said 6 pigeons, but how many across how many like total data points?
Yeah, we actually took 50 sessions of data points. Every session was about approximately 45 minutes. And
50,
and what were and then you collected data each minute or every second?
Maybe.
Yes.
Is response rates that you were using, right?
Yes.
So you're getting probably like a couple dozen thousand. You get like 50 responses a minute times 45 times 50 sessions.
Yeah, so that's like thousands of.
And we actually have given less and less to the model to see how well the ability is doing compared to the amount of data.
Were these data? So these were past performance. So these data were all labeled.
Well, when we fed the model, we fed them without labels. Yes. So
So you were using unsupervised learning or supervised? Supervised would be labeled. So unsupervised without labels.
Yes, and the good thing with the spiking neural networks is that the sample, every sample that was fed only had 90 points. So it wasn't that every sample had a lot of, the 1,000 points were all together. We didn't need it that. We had small samples feeding in the neural network to see how it responds in relation to the amount. And it did well, even when we dropped up to 50% of the data we were using, but after that, it wasn't doing as well. Well,
Cool.
I'm putting it all in writing, and I'm thinking of taking it out there to see the response. I'm not sure
Yeah.
yet. On you.
Yeah, you should definitely do it. I mean, I think people would be really interested in that. And I think a lot of people are really interested in how to use AI and machine learning in behavior analysis. And I think there are people that are submitting articles to JAB and Java, and everyone's just kind of trying to figure it out, like, what do we do with this tool? So if you have a great demonstration of that, I say, yeah, publish it.
Okay, thank you.
Yeah, that's
How
cool.
can I stay in touch with you guys, because I'm so far
Oh,
away?
sure. So I would say if you go to that codingbehavioranalysts.org,
Yes.
there's instructions on there for joining our Slack channel.
Okay.
And when you do that, then that's essentially like a big, like AOL Instant Messenger or like Google Chat. It's just a space where you can communicate with other people just by typing. And so then there's a bunch of people around the world, and so they all kind of get on and respond whenever they have time. And there are different channels, so like based on interest. Like if you're really into data science, there's one. If you're into Python, there's one. If you're into R, there's one. I'm highlighting the ones I visit often. Article and book sharing. Yeah. But then you can chat with anybody at any point in time. That'd be cool.
Thank you. Thanks. Thanks,
Oh,
guys.
yeah. Thanks for sharing your work with us. Oh, I forgot to stop recording.